Math and beats. All right, we're going to talk about logical connectives and truth tables. What's this all about? Well, what we're going to do is introduce vocabulary and notation for compound statements, and then we're going to look at the corresponding truth value tables. As you recall, there were several different types of logical connectives that we could use. And the first one is the not connective. So for all these examples, including the one we're about to look at, let's let P and Q be statements. Then not P is what we call the negation of P, and it's denoted by over here this little tilde in front, P, not P. On the right here, this thing, that's little mini truth table. Truth table is just a way of organizing all the different possibilities of the statements of concern and determining in the end what the compound statements truth table or truth values, collection of truth values, looks like. So if I have a statement, whatever it is, P, it can either be true or it can be false. So you talk about not P. Well, if P is true, then not P is not true. That's false. And if P is false, then not false is true. That is the truth table for not P. Now we're going to look at all the connectives real quick here before we do an example. The next situation is if we have P and Q, denoted by this caret looking symbol in between P and Q. We call this the conjunction of P and Q. So now that we got two statements involved, think about all the different possibilities of what P, Q could be. P could be true, Q could also be true. P could be true again with Q false. P could then be false with Q true, and the only last possibility is both of them are false. So that's it. There's only four possibilities if we have two different statements involved. Now, what if we then say P and Q? Well, if we have a true statement and another true statement, if this is true and the other one's true, they're both true, P and Q, that entire statement is true. But on the other hand, we have a true statement and we also have a false statement, and we say P and Q, this is going to be false. For instance, what if P is the statement 1 plus 1 is 2? That's true. And Q is the statement 2 plus 1 is 7. That's false. So I say to you, 1 plus 1 is 2 and 2 plus 1 is 7. Well, that's a false statement. So same can be said the other way around. If P was false and Q is true, you can't have a true statement with one of them being false and you put them both together. The whole thing's false. Also goes for P and Q, both being false. 1 plus 1 is 2. Just change that. 1 plus 1 is 9. 1 plus 1 is 9. And 2 plus 1 is 7. That is a false statement. So the conjunction of P and Q is only true. P and Q are both true. What about the disjunction down here? P or Q is now what we're talking about. Or instead of and. Symbol, same symbol for the conjunction, but it's upside down now, see? So we're going to construct the truth table now. Different possibilities. True, true. True, false. False, true. False, false. So what if we got a true statement or a true statement? The whole statement's going to be true. Again, 1 plus 1, 2. 2 plus 3, 5. 1 plus 1 is 2, or 2 plus 3 is 5. True statement. Now turn Q to false. How about 2 plus 3 is 9? Then you say 1 plus 1 is 2, or 2 plus 3 is 9. The whole statement is true because we only need one of them to be true in order for it to be a true statement. This is true, or this, blah, blah, blah. So the whole thing is true because one of them is true. So that's also truth value for the other way around. P false, Q true. Then P or Q is true. Finally, false statement with another false statement. Change the P statement to the left to 1 plus 1 is 7. And you say 1 plus 1 is 7, or 2 plus 3 is 9. The whole thing is false. Neither of those is true. So, quite the contrary to the conjunction, the disjunction is always true, except when P and Q are both false, then it is false. So there's the first three. The next two will be a little more involved. The conditional statement, which is if P, then Q, the conditional. Denoted over here, but it's arrow looking thing. So just for some reference purposes, the P part, the if P part, that first part, we call that the antecedent. And the then Q part, we call that the consequent. So it's just a way of keeping track of which one's the if part, which one is the false part. Excuse me, the then part. All right, different possibilities for P and Q again. True, 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 false, false, true, true, true. So the whole thing here is you start with something. If P, then something else, then Q. So let's just suppose that P is going to represent the statement, it is cloudy. And Q can represent the statement, I wear my hat. Excusez-moi. Okay. So, think of this, they're both true. If it is cloudy, true. Then I wear my hat. True. So, the premise of being if it's cloudy, then I wear my hat, it's true. True statement should always follow another true statement. If, however, we go to the second row here, if P then Q, but P is true and Q is false, that entire thing is going to be false. A false statement should never come from a true statement. Something that's true should tell us something true. Now, the third and fourth rows, I think, are a little more abstract. Let's go false then true. So, let's suppose it is cloudy, then I wear my hat. And if P is false and it is not cloudy, so it's sunny skies, and I still wear my hat, then just because I'm wearing my hat and that's true, it's still true, right? The whole point of it being cloudy didn't negate the truth value of me wearing my hat. I might just be happen to wear my hat because I love this hat. And so the fact that I'm wearing my hat didn't falsify the fact that I'm wearing my hat. So that statement is true. And down the last row that I just saw should be false, false, not true, true. But let's just suppose they're both false now. I didn't wear my hat. It's not cloudy. And did it falsify the original implication that if it's cloudy, then I wear my hat? No, I didn't wear my hat. It's not cloudy. Nothing wrong with that. It did not make any difference to the original statement. Therefore, it's true. And hence, the only time that a conditional can be false is if the first part is true and the second part is false. One more, and then it's a more complicated example. Here we have a biconditional statement. That is the if and only if statement. P if and only if Q. and denoted by double arrow here. This is actually the conjunction of P and Q. So we want to look at the combo of those two. So once again, we fill in our truth table here with the different possible combinations of P and Q, remembering that the last row is false, false. And then we're going to just construct this column by column till we get to the desired result. We need a column of if P then Q's, a column of if Q then P's, and then a column of if P then Q and if Q then P's. So we saw a moment ago the conditional statement. The only time it's false is if the first part P is true and the Q is false. That's the second entry right there. And then the rest of the time it's true. Now switch it around, same thing can be said, but now we're making Q the first part here, the antecedent. And so the only time that that's going to be false is if P is false, Q is true, meaning Q is implying something false. So that is this entry right there. The rest of the time it is true. And now we look at the conjunction of these two columns. And that is only true if they're both true. So true in the first part, but then false in the second two, and then true in the last part as well. So notice that a biconditional statement is true only if P and Q have the same truth values. Interesting. Finally, let's look at a more complicated example here where we have a bunch of stuff going on all at once. The first part right here, we're going to go ahead, the left-hand side, and construct that. The right-hand side we'll do next, then we'll combine them through the if and only if statement. And what this statement is saying is not P and Q if and only if not P or not Q. When is that statement true? When is that statement false? Let's go ahead and start with the left side, but before that, we got to make sure we fill in our P and Q's here. So all the different combinations, just like before. And then we need P and Q's. We also need not P and Q's. So the negation of the third column is the fourth column. P and Q only true if they're both true. So that's that first entry. The rest of the time it is false. You negate all of those. Not P and Q, false, true, true, true. All right, left-hand side. So now the right-hand side, we need a not P, we need a not Q, and we need a not P or not Q. So we look at the first column over here for P's. We're going to negate all those in the not P column. So it's going to be false, false, true, true. Same with the not Q. Look at the Q column over there. It's going to be false, true, false, true. And then we're going to look at the disjunction of P and Q. So putting the or symbol between these. That is always true unless, of course, P and Q are both false. So the first is false, then true, true, true. Finally, we look at the very last step, which is combining the left side and the right side together into an if and only if statement. So there we have written it at the top. I'm going to be focusing in on these two columns right there, and I'm combining them through an if and only if statement. Remember from the previous part, the if and only if statement is true if both sides have the same truth value. So we see in the very first entry, right there and right there, both false, same truth value. That means this statement is true. Go to the next one. True, true. Same truth value again, so that's true. And in fact, next two rows are the same. Hence, this statement, this complicated random statement, is always true. That's pretty nice. So no matter what you do, it's going to be true. When you have this situation where it's always true for all values of P and Q, we call that, if I could circle, a tautology. Tautology. However, if you ever encounter a situation in which statements are always false, call that contradiction. It can happen. And there you have it. There is a little mini lesson on logical connectives and truth tables. So now it's time for beats. Later.